14th, darling. It's Kenny.
It's generated by some kind of super advanced, deep fake quantum computer mumbo jumbo. They could make Salma Hayek blow an orangutan if they wanted to.
Let's do this.
Quantum computers.
Quantum computing. From a quantum computer.
What up, y'all? What's not talking about the mysterious quantum computer? What can they do? Who is building it? How will the world ever be the same? So, most importantly, before we get into all the different things that they can do, they can do a lot. Some of them have even simulated black holes. First, let's take a look at the history.
In the 1980s, one of the most important physicists of the 20th century encountered a major roadblock. Richard Feynman was hungry for a window into the quantum universe. But quantum systems, by nature, are fragile, and the information they hold hides from us. Because Feynman couldn't directly observe quantum events, he wanted to design a simulation. It quickly became clear that his computer wasn't up to the task. As he added particles to the quantum systems he was modeling, the cost of computation began to rise exponentially. Feynman concluded that classical computers just can't scale up fast enough to keep pace with the growing complexity of quantum calculations. Then he had a breakthrough. What if he could design a tool made up of quantum elements itself? This instrument would operate according to the laws of quantum physics, making it the perfect way to probe the mysteries of the quantum realm. The idea of the quantum computer was born, and by dreaming it up, Feynman had started to build a bridge between quantum physics and computers.
Quantum computers were created out of the necessity to calculate an increasingly complex number of growing possibilities on an atomic level.
And then quantum computers was the revolution in hardware. Quantum computers was the revolution in hardware.
It's essential to start by understanding what makes it quantum in the first place. This means that we need to talk about what's at the heart of quantum physics, a concept called amplitudes.
Quantum mechanics, at its core, is a change to the rules of probability. And this is also where the power of quantum computing comes from these different rules of probability.
Before you measure a subatomic particle, you can think about it as a wave of probability that exists in a kind of black box, a quantum system with many different chances of being in many different places.
Amplitudes are closely related to probabilities, but they're not probabilities. A key difference is, while probability is always a number from 0 to 1, amplitudes are complex. And what this means is that they obey different rules. If I want to know the total amplitude for something to happen, I have to add up the amplitudes for all the different ways that it could have happened. But when I add up amplitudes, I see something new, which is that a particle might reach a certain place one way with a positive amplitude and another way with a negative amplitude. And if that happens, then those two amplitudes can cancel each other out, so that the total amplitude would be 0. And that would mean that that thing would never happen at all. This is sort of the central thing that quantum mechanics says about the world, right? That the way that you describe a physical system is by a list of amplitudes, and the way that a physical system changes over time is by a linear transformation of these amplitudes.
But how can quantum computers use amplitudes to store and manipulate information quantumly? This is a qubit. It's the basic computational unit in quantum computing. Qubits are like bits in a classical computer, but with a crucial difference. A bit is binary. It stores information in strings of binary digits that can only be 0 or 1. But qubits are made of subatomic particles, so they operate according to subatomic logic. Qubits can be 0, 1, or what we call a linear combination of 0 and 1. This fluid combination of amplitudes is at the core of quantum computing. Before you measure a qubit, it exists in a state called superposition. You can think about it as a quantum version of a probability distribution, where each qubit has some amplitude for being 0 and some amplitude for being 1. Superposition is the reason why it takes a vast number of classical bits to describe the quantum state of even a tiny number of particles. When two or more qubits are in this closed state of superposition, they relate to one another through the phenomenon of entanglement.
Because qubits can be superpositioned, quantum computers possess the ability to calculate a seemingly endless number of possibilities. But what else can they do? And what does this mean? Prediction, pre-crime, and facial recognition.
Positive for Howard Marks. Placing you under arrest for the murder of Sarah Marks. Now, it will take place today on the 22nd at 0800 hours.
Highly advanced deepfakes. Virtual reality and augmented reality simulations within other quantum computers within parallel universes. Extremely advanced and sophisticated navigation systems capable of simulating complex courses through black holes.
Ready? Main engine ignition in 3, 2, 1, mark.
Traveling to the future or even the past instantaneously.
Mission test on my mark. 5, 4, 3, 2, 1, mark.
Openly, Pandora's box. Overcoming language barriers.
Instantaneously change how we interact with each other in terms of language barriers, all these issues that we have currently. If there's something like augmented reality, and we have something like that, you're going to be able to instantaneously translate what people are saying. I think that would change just human perception across the world.
All this and more. Quantum computers could even unlock the mystery of anti-gravitational momentum, or stellar engines, perhaps even Dyson spheres. The universe at humanity's fingertips.
The future has arrived, and it's quantum.
The entanglement of qubits allows quantum computers to simulate different things simultaneously and predict outcomes seamlessly. New studies have also shown that quantum computing can improve carbon capture technologies. But with so much power at its disposal, can we be certain that the revolution that quantum computers bring is one that has our best interest in mind? With quantum computers already on the market in massive scale, who will protect people from the potential dangers of advanced artificial intelligence and quantum computing? The government? The police? Big tech? Quantum computing will change our world in an unprecedented way, but what do you think? Is it dangerous, or is our society ready? Holla at me. Have a good night, and thanks for watching the video.
To explore physics. Now, whether that's going to make anybody any money, whether there will be practical applications in the near term, that's still very much an open question. But at least for physicists, it's an exciting time.
The truth is, the most important application, I believe, of quantum computers is something that we don't know yet. I'm sure that once we have a quantum computer to play with, we will find amazing applications that we can't yet.
If you destroy that, you destroy everybody inside every fictive universe above this one. You! Billions of simulated souls who consider themselves to be real will die. Do you really want all that blood on your hands?
I mean, define blood for me here.
Okay, this is a quantum computer, right? We barely know how it works. It's basically magic. The reality we're in will cease to exist.
Would I die?
Instantly.
Put that fucking axe down, Annie Murphy. Now!
Listen to her, Joan.
Put it down!
Do as you're told.
I can't. Because the fact that I'm standing here right now means that Source Joan already stood here in reality, so it doesn't matter what I want because the events that this is based on have already happened. It's not my decision. It's Joan's.
Okay.
Tell me.
All right, Joan.
She's doing
Joan, put
it.
the axe down.
Joan's